All right, guys. So 7.3.2. This is going to do a translation on the t-axis. Okay, and the first thing that we discuss in this section is the unit step function. Okay, so this is like a cursive capital U, minus A. So this is a step function where you have, like think of an on-off switch. Has to do with sort of, after like A seconds, then it switches on or off or whatever the situation is. Okay, and just to go over what a step function looks like, right? We know it looks like this, where you would have let's say A is here, right? Open circle, and then it jumps up to 1, and then it continues like that. Okay, so there's your unit step function. Now, a couple things that you could do with this is it doesn't, with that, we could have functions that look like this. Where you start out with that 0 to here 1, right? Because of the 1. Open circle at 1, and then pop down to this function here. And that'll keep going. So there's an example of an idea of a step function that is not just a constant. Okay, so the general rule that we're going to use here is f of t equal to this piecewise g of t so it looks like that, and then this is the notation that is equivalent. You would have g of t minus g of t, and then your step, and then plus h of t with the same step. So that's an example there that you would want to use. Also, another example to say it looks like this. Okay, so when you look at that setup that we did prior, we could write this one as f of t equals, so that first thing is 0, and then because these are two different values, all right, you're going to have g of t and then times the step function at a minus the step function at b. So it looks sort of like that, right? And then you would have plus this other part, but because that's 0, this other part here, that's 0, so you don't need that. But that's if you have something similar to that. So for example, like let's go to a basic example here of, so it's 2 minus 3. Okay, so this is telling you where the steps are actually changing. This value right here is the start. Okay, like where do you start your graph? That's right there. This is telling me that I'm going down 3 at 2 and up 1 at 3. So what do I mean by that? So here you start at 2 until you get to 2, right? So it's 1, 2, open circle, drop it down 3 units, right? We'll wind up at -1. You can see it went down 3, that's where I'm getting this portion. And then up 1 unit at 3. So it looks like that. Okay, here's another example. Okay, and you know, you could write it as a step function this way, but I kind of want to show you how you could use the unit notation for a function rather than, so these two are equivalent, right? But if we're just focused on this, when you're graphing that, I know, right, my starting point is going to be that 20t. So at 0, you're still starting at 0. And then until you get to 5, right, we're using that function here, like that. And at 5, it would be 100. So that's an open circle at 100. But then do the same thing. Really what you're doing here is just subtract if you subtract these two terms, you would get 0, and that would bring you down here, and then you would have that end of your function going that way. Okay, so that's the graph part of it. And then what we're going to do is mainly use this to solve the differentials. So if you have this second translation theorem and the Laplace of a function t minus a, so again a little bit different when you're doing these problems. You want to have a function of t minus a, then that unit step function t minus a, so that has to match, and if that happens then you could translate it as e to the negative as, and then a function capital F of s. So let's go back to this one that we had to start, the easy one where you're going down, start at 2, go down 3, and then go up 1. And because you don't really have to worry about making it a function of t yet, a function of t minus a yet, it's alright. So here we'll have, I'm just going to break it up into different transformations. Okay, so now when you do this, we're going to get like capital F of s is going to equal, now this first one, right, that we have, the 2, that's an easy one because that's just go back to your regular transform, right, your Laplace transform, so you get 2 over s. Now just remember, 2 over s, because it's just a constant, you're going to have the same thing for each of these. Like this is a 3 over s, but because of the unit step function, I need to have that e raised to the negative 2s. And then the same idea here. I know you don't see a constant, but you know it's going to be 1 over s and then e to the negative 3s. And that's how you would do your transformation that way. So now if you're doing an inverse, so an inverse would be a little bit, tougher in the sense that if you have some e to the negative as, right, and then you have a function capital F of s, you can then do the transformation where you have f of t minus a, and then u t minus a, that unit step t minus a. So if you have something that looks like this, 1 over s minus 4 e to the negative 2s, right? So I know, notice function of t minus a if you have that unit step. So I know the unit step has to be t minus 2 because my a is 2. Now here, this portion, right, that would normally be an e raised to the 4s, okay, e raised to the 4s. Okay, but because we wanted a function of t minus 2, instead, e raised to the 4t, but, because we want it to be t minus 2, I'm going to make it e, so it'll be e. You still want that 4, but instead of just a t, it's t minus 2. And the reason for that is because that t minus a there, it's as a function of t minus a. So then this would represent that function in terms of t minus a. So there is your final answer for that one. Okay, for B, we're going to do a trig. So say you have s squared plus 9, and then e to the negative pi over 2s. Okay, on this one, same idea, because I know I'm going to have a unit t minus pi over 2 when I do my cosine in this, right? So it'll be cosine 3 times t minus pi over 2. Now you can use your trig, and if you want to simplify that, I think it comes out to like a negative sine 3 pi over 2, something like that. So you could do it that way, but that would be your inverse transformation as well, okay? All right, so with that, then we need to do what we want to. We want to solve these differentials. All right, so if you have something like this, actually we're going to do just the first derivative. Okay. And if I have f of t equal to 0, and then 3 cosine t, where t is greater than or equal to pi. So this is the differential we want to use here. So another thing here is you could write this as 3 cosine t and then that unit step t minus pi. Okay? So that is one thing that you have to do. And now when we do our transformation, right, so I do Laplace, everything else stays the same, right, plus Laplace of y, and then I'm going to do the Laplace of this step 3 cosine t. Okay, so we'll get, just use our rules like s, y capital Y of S minus Y of 0 plus Y of 0, nope, Y of S, capital Y of S equals, and now use your rules here with this 3 cosine t, okay? But the one thing that I can change to make it a little bit nicer, because this is trig, right? If I want to do cosine of t minus pi, right, that's just going to be a negative cosine t. So we could change that to be the Laplace of negative 3 cosine t, and then our step, which means that I'm going to get, just going with the cosine part, so I have negative 3s over s squared plus 1, and then e to the negative pi s. Okay, so now we'll have, let's simplify some of this. So I'll have s plus 1 y of s, and then my initial value was 5, so minus 5 equals negative 3s s squared plus 1 e to the negative pi s. So let's solve for y of s, and I get negative 3s e to the negative pi s all over s plus 1 and s squared plus 1. Okay, and then plus 5 over the s plus 1. So the 5 over the s plus 1 is the easy one. So I'm going to rearrange some things, right? Let's put the 5 over the s plus 1 because that's the easiest. And then here, what we have, again, is, right, you have to do a partial fraction, which we did way back earlier. So you can look that up on how you do this. Now, one thing that might be easiest for you guys is maybe just to kick out like minus 3e to the negative pi s, and then do your partial with the s over s plus 1 s squared plus 1. That might be a little bit easier. This is an s, not a 5. Okay, so when I did it, I didn't do that though, and now that I'm looking at my work, so I had it like 5 over s, and then I did my partial fraction, but I kept this e to the pi s. So what happened was it wound up being like a plus 3/2 e to the negative pi s over the s plus 1 minus 3/2 e to the negative pi s over s squared plus 1, and then the last one was minus 3/2 s e to the negative pi s over s squared plus 1. So when you're going backwards from here and you're doing the inverse of each, so the first one should be pretty easy because we know that's just 5e to the negative t. Okay, the next one, so each time you see this e to the negative pi s, e to the negative pi s, e to the negative pi s, I know for each one of those I need to have that unit t minus pi for each one of those terms. So if I'm focused on this first one, okay, that t minus pi has to be in place of the t. Now think about this as just a, like the 3/2 is going to stay, right? So, but just think of it as 1 over s plus 1, and we know that would be e to the negative t. But because it's a u attached to that e to the negative pi s, we are going to write it as e raised to the negative t minus pi, just like that. Okay, same idea here. I'm going to have minus 3/2, and then I know my unit function will be in there as well. So what that should look like is, so you don't have the 3/2. So what if you just had, like, don't worry about the e to the pi s, just this s squared plus 1. That would then be sine. So it's sine t, but instead of t, I got to do t minus pi again because of that unit, that e to the negative pi s. And then this is t minus pi that way. And then the last one would be a minus 3/2. And if you notice, again, s over s squared plus 1, that's cosine. So cosine t minus pi, and then u to the t minus pi. Now, with all of these, you can simplify it down, right? Because it is trig. So if you want to do like this one, I'll just keep the same. I'll just write it pi minus t, and then, but on here, like if you are moving pi units to the for sine, so if you're moving pi units to the right, really you're just it's just going to be a negative sign. So this winds up being 3/2 sine t. Not that this is necessary. I mean, I think you'll still get credit. And the same idea when you're moving cosine over to pi. It's going to be the negative as well. So then it winds up being another plus 3/2 cosine pi, and then your unit step. So you can use your trig. This is a little bit neater, but this is the setup that you have here. All right. And that's the last part of section 7.3.